NASA is developing the capabilities to send people into deep space. To accomplish this, we need to extend our knowledge of how to operate in space. NASA is developing habitation systems that provide safe and sustainable space-based living quarters, workspaces, and laboratories. Expandable habitats are one option. These potentially weigh less and occupy less volume on a rocket while allowing for additional space for living and working. However, testing needs to be done on the design performance of expandable habitats. The Bigelow Expandable Activity Module, or BEAM, developed under contract with Bigelow Aerospace, provides a test platform for demonstrating the thermal, structural, radiation performance, mechanical durability, and long-term leak performance of expandable habitats. The beam will be transported to the International Space Station inside the SpaceX Dragon's supply vehicle's trunk. Once Dragon is berthed to the space station, flight controllers at Mission Control in Houston, Texas will maneuver the station's robotic arm to extract beam and attach it to the rear port on the Tranquility node. After all preparations are complete, crew members will begin inflating the structure. This will be the first time an expandable habitat has been deployed on station, so the procedure will take place slowly to closely observe the expansion process and maintain the safety of the crew and the station. During this time, beam will expand from its packed dimensions of 5.7 feet long and just under 7.75 feet in diameter to its pressurized dimensions of 12 feet long and 10.5 feet in diameter. Once beam is fully expanded, the crew will pressurize it and test it for leaks. After this, beam's pressure will be equalized with the station pressure, and the crew will enter the beam and install sensors. The ground-monitored sensors will autonomously collect thermal, impact, and radiation data throughout the 2-year on-orbit life of beam. These experiments will help determine whether expandable structures will provide a viable, lightweight option for future space habitats.